Okay, good day everyone. We are now on the last topic of our module, summarizing and organizing data, and this is the different numerical methods. We already discussed tabular method and graphical, so today we'll be discussing the measures of central tendency, measures of dispersion, shape, and data locations. Before we will start our topics, let's focus first on this example. On this data, now we have the ages of 40 students in a 60-point test. So these are the 40 values of the students. So the first thing that we have to do is we have to create a table for this one, a tabular form and a sorted form of the values. So this is the tabular form equivalent of the data, and these are the sorted values. Why do we have to do this? Because in our discussions we have different formulas. For example, for the measure of central tendencies, we'll be using a different formula if we will deal with the table, and a different formula for this raw data. By the way, data that are presented in a table are called group data, and data presented in this form are ungrouped data. So raw data are the ungrouped data. So for the first measure of central tendency, we have the mean or the average of all the data. There are again two ways. One is using the summation of all the frequencies multiplied by the class marks divided by the sample size, or you can use the summation of all the values divided by the sample size. Now, since we have here frequencies and class marks, therefore this will be used for the group data, or those presented in table form, and the other one will be used for ungrouped data or the raw data. So the uppercase letter X here represents the value of each each of the data, and N again is the sample size. Okay, so let's start with this table here. So here's the solution for this table on how do we get the mean or the average. Now first is we will solve for the mean of the ungrouped data, so using this table. Now remember, we will be using the frequency and the class marks. So the frequency are the lowercase f, and the class marks are the lowercase x. So when you say summation, we will be summing up all of the products of the respective of the frequency and the class mark of each respective of each row. So that will be 23 times 8 plus 28 times 9. By the way, it was exchanged here, so this one is the class mark, this is the frequency. So that's 33 plus 6, 33 times 6 plus 38 times 6 plus 43 times 5 plus 48 times 4 and 53 times 2. Then you have to divide it by the n, or the sample size. So for our case, our sample size is equal to 40. So summing all them up using your calculators, that will then be equal to 34.375, or you can approximate it if you are asked on the approximate value. So that's 34. since our data are in whole numbers, so for representation we will be using the whole value, that's 34. Next we will calculate the mean or average for the ungrouped data. So in calculating the average or mean of the ungrouped data, all you have to do is add all of these values. That's starting from 21, 36. This is based on the unsorted now. So however, you can still use the sorted form. So from 21 until 55, the result will be just the same. So divide them all, sum them all of the 40 values, and divide them by 40, and you will get the value which is equal to 34, exactly 34. Now if you were asked which is better, the group or ungroup, now it depends. Now if the data given are in tabular form or group, then you have to use this formula. But if the raw data or the ungrouped data were given, so it would be better to use this formula or equation. Okay, so that's okay. This is the whole solution for the mean. Now you have the mean for group data and the mean for ungrouped data. If you would get check the exact value, so they have a difference of 0.175. Now you have to understand that the mean of group data would also be not accurate compared to the raw data or the ungrouped data, since here we're actually estimating them now based on this table, but for this portion here we are calculating the exact mean of the given data. After mean or average, we have the median. So median is another term for median is the middle value. The middle value of your data. There are still two ways of calculating the median for grouped and ungrouped data. For group data, we will be using the lower class boundary of the median class containing the n halved entry. So that would mean if our n is equal to 40, then half of n is 20. So the 20th data, the class interval that contains the 20th data will be your median class, and we have to get the lower class boundary of that, the frequency, and the less than cumulative frequency of the class before the median class, so meaning the previous class interval. For ungrouped data, there are two ways that we can get the median, or two conditions. If n, or the sample size, is odd, so I will have to get n plus 1 over 2. So if our data is 41, so that's 41 plus 1 over 2, so that's 42 divided by 2, which is 21, which means the 21st data will be our median. However, if it's even, if n is even, then we'll have to get the average of the two, the n over 2 and the n over 2 plus 1. That is n over 2, then add 1 to n over 2. Then let's have this example. So if you will recall our data, okay, so let's start. Okay, so we'll start with the group data. Now again, remember that LB sub I is the class boundary, lower class boundary of the median class. Now, recall that LB sub I n over 2 summation of f sub I and fx are known values. Now n over 2 is, our n is 40, so n over 2 will be equal to 20, which means our median class is where the 20th data is located. So if you would check our cumulative frequencies here, it actually tells us where the median class is, or where the 20th data is. So the first class contains the first and the 8th data. The second class interval contains the 9th and the 17th data, and the third class interval contains the 18th and 23rd data. So if you would take at the values here, so the less than cumulative frequency tells us the last value for each class interval. So in the fourth class interval, our data will start from the 24th value, or 24th data, until the 29th data, and so on. Which means our lower class boundary for the our median class is the third class interval, and the lower class boundary will then be equal to 30.5. So again, n over 2 represents the 20th, the n over 2 data. So our lower class boundary is equal to 30.5. Next is we will identify this summation of f sub I. Again, this represents the class, the greater than cumulative frequency of the previous class interval. So that's 17 now, which is equal to 8 plus 9. So this represents the summation of all the frequencies of the previous class intervals also. Now that is 8 plus 9, or if you would refer to the less than cumulative frequency, that is 17. Then f of x sub x, f sub x is the frequency of the median class, and that's 6. Then our class width, now that's 26 minus 21, and that's equal to 5. Or you can calculate 30 minus 25, that's still equal to 5. And substituting all of these values to our equation, we'll have the lower class boundary of the median class plus n over 2, that's 40 over 2, which is equal to 20, minus the summation of the previous frequencies divided by the median class's frequency multiplied by the class width. Then you'll get 33. So I think that's exactly 33. So our median for the group data is equal to 33. Now let's try to solve the median for the ungroup data. Take note that our n is 40, which means our n is even. So we'll have to get the x sub n over 2 and the x sub n over 2 plus 1. So x sub n over 2 is 20. Then therefore our n over 2 plus 1 will be equal to 21. This means that the median is located in between the 20th and the 21st data. So if you would check here, this is our 20th data. Now x sub 20 is 32, and x sub 21 is 33. You have to remember that in order for us to get the median, we have to sort the data first. Okay, and after that we will get the average. Now we will divide x sub 20 and x sub 21 by 2. So that's 32 plus 33 divided by 2, and we'll get 32.5, approximately 33. Now you have to take note that these are just approximations. Now because in our data we don't have values that have decimal points, so we'll be getting the nearest value based on the real value. So since we have 32.5, then therefore our median is 33 when 32.5 is rounded. However, when we will be using median, mean, and so on for in a solution, we will have to use the exact values, especially in plotting the data later on. So again, these are our medians. Now for the group data, we have 33 exactly. For ungroup data, we have 32.5. Approximately, it's 33. So this is the whole solution. Let's proceed with the mode. Now, the mode is the value which occurs frequently among the data. So that would mean the value that occurs frequently, which this means that is the value which has the largest or the greatest frequency. So this is how we calculate the mode. In group data, we will use this equation. Now that's LB sub I. So that's the lower class boundary of the lower class boundary of the model class. Then the sum of the frequencies. Oh no, that's the difference of the frequency of the model class. Next, subtracted by the frequency of the next class interval. That's your delta f sub 1. Your delta f sub 2. So if you would recall back our definitions. So it's before it. No, delta f sub 1 is the difference between the frequency of the model class and the frequency of the class before it. Delta f sub 2 is the difference between the model class and the frequency of the class after it. Now LB sub I is not the lower class boundary of the median class, but rather the model class. Now when we say model class, this is the class which has the highest or the largest frequency. So for in our case, the model class or the class interval which is the highest or largest frequency is the second class interval, because its frequency is equal to 9. So this will be our model class. So therefore, therefore our lower class boundary for the model class is equal to 25.5. Again, since it has this class interval as the largest or highest frequency, and our delta f sub 1 will then be the frequency of the model class subtracted by the frequency of the previous class interval. Our delta sub 2 is the frequency of the model class subtracted by the frequency of the next class interval, and that is 6. So delta f sub 1 is 1, delta f sub 2 is 3. Of course, the class width is still 5. No, it will be constant for all these as long as we use these values or data. Then substituting all of the values, you have 25.5 plus delta f sub 1, which is equal to 1. Divide them all. Divide it by 1 plus delta f sub 2, which is equal to 3. Then multiply the term by the class width, which is 5. Then we'll get 26.75. We can approximate it to 27. Therefore, our x hat x hat or the mode is equal to 27. Now for ungrouped data or raw data, we'll just have to count. If you would observe this table here, or this sorted data here, 28 has the largest occurrence. Now therefore our mode, our x hat, is equal to 28. So that's how we get or solve for the mode of our data. Okay, we are done with the measures of central tendencies. So we will proceed with the range and the variance. We already know how to get the range, and that is the difference of the data, which is the maximum largest values value subtracted by the lowest value for data. Then we'll calculate variance after, or specifically sample variance. If you would see variables denoted with our alphabet, not just like this S. If you recall, our mean, median, and mode were denoted by x, lowercase x. So those refers to sample, sample mean, sample mode, sample median. Then this variance here refers to the sample variance. If we will want to get the population variance, we will be using a different character, and that's sigma, Greek letters sigma. For mean, median, and mode, we will be using the Greek letter mu. Anyways, we will be using with the samples. Now when we say variance, this is actually the degree of spread within the distribution. Now this can be calculated either by using this for group and this one for ungrouped data. So this is how we solve for the range again. So our range is equal to x max minus x mean. Take note of the letters that I'm using. Uppercase letter X refers to the value of your data, each of the value of your data, while the lowercase x, especially when you have x sub I, refers to the class marks. Lowercase x, which has a bar, refers to the mean. Lowercase x, which has a curl, refers to the median. And the lowercase x, which has a hat, refers to the mode. Then next we will calculate for the variance. So if we will be using the group data or the tabular form, then we will have to sum up all of the product of the frequency of that class interval with the square of the class mark. So again, this is your lowercase x sub I, this is your f sub I, which means this is your x sub 1, this is your x sub 2, x sub 3, until x sub 7. So this is your f sub 1, f sub 2, f sub 3, until f sub 7. So what we have to do is multiply 8 by the square of 23 plus 9 times the square of 28, then 6 times the square of 33 plus 5 times the square of 43 plus 4 times the square of 48 plus 2 times the square of 53. Then sum them all, multiply it by 40. So the sum of the product of the frequency and the square of the class marks will be multiplied by 40. After, okay, we will subtract it. Sorry for that, this is actually minus. Then after, we will subtract it by the square of the sum of the products of the frequency and the class marks, which means we have to sum up all of the product of the frequency and the class mark, then raise them to power 2. The sum will then be raised to power 2. So that's 8 times 23 plus 9 times 28 plus 6 times 33, 6 times 38, 5 times 43 plus 4 times 48 plus 2 times 53. And sum them up, raise it to power 2, and divide it by n times the quantity of n minus 1. Commonly, n minus 1 refers to the degrees of freedom. Now you can check for the meaning of degrees of freedom. What does it mean when we say degrees of freedom? Anyways, we'll just proceed to the calculations. Now if you will sum these values here, you'll get 50,565. These values on the other side, or terms or group, is 1,357. So multiply 50,565 by 40, subtract it by the square of 1,375, divide all of them by 40 times quantity 40 minus 1, and you will get exact value, which is 84.599359. Then we can round it off to 84.60. So for group data, our variance is equal to 84.60. Now let's check with the ungrouped data. So the equation is the value, subtract it by the mean. If you will recall, our mean is equal to 34.2. So each of the values will be subtracted by the mean. You don't have to worry if the value will be negative or positive, since we have raised it to an exponent which is even, therefore all of the values will be positive. So that's these. No, that's 21 minus 34.2, 22 minus 34.2, then 23 minus 34.2, then you raise all of the differences by 2, now raise to power 2. You can still calculate variance for unsorted data, but I would prefer you calculate it using the sorted ungrouped data, since it would be easier for you to trace if your calculations, and divide it by the degrees of freedom. For the raw data, now we have 83.75 approximately. If we will compare it to the previous one, for the group data, that's 84.60. So if you would notice, now there would always be difference between the calculations of group and ungroup data, since for group data, more or less they are just approximated, while these ungrouped data are the real or exact samples or data. Next, we'll get or solve for the standard deviation and the coefficient of variation. So the standard deviation is just the square root, the positive square root of the variance. Take note, we are using positive, since the square root of a number has two values, a positive and negative. For standard deviation, we will be using the positive square root of the variance. So this is, or the standard deviation measures how the average score, how the mean deviates or spread, or the average score deviates or spread from the mean. So meaning unsa kalayo na imong data sa imong mean. The lower if we will get a value, before we can decide how the values or data deviates from the mean, so we have to get first, the coefficient of variation. Now, the coefficient of variation is calculated using this one. That's standard deviation divided by the mean multiplied by 100%. Therefore, coefficient of variations are expressed in percentage. If you will get a coefficient of variation which is less than 10%, therefore we can say that data are clustered to the mean, meaning dugo ra kay sila sa tong mean. Otherwise, data are scattered or far away from many of the data deviates from the mean. So using our examples, using our example, the table and the sorted data, we have these. So for the group data, since we already have the variance, then we don't need to, we just have to get the square root of the variance, and that's square root of 84.599359. As you notice, I use the exact value, not rounded value, because there would be a rounding error when you use the rounded value. Now we can only round values if that will be our final answer. So for this case, we'll use a value just 2 decimal places, and that is approximately 9.20. For the standard deviation of our ungrouped data, so we'll get 9.15. So determine if how spread is, we'll get the coefficient of variation. Now in agricultural research, they have a range here. If you will get a coefficient of variation which is less than 10, then we can say that your data gathered is very good, meaning they are clustered. We can also say good if your coefficient of variation ranges from 10 to 20. If your data ranges from 20 to 30, it's still acceptable, but greater than 30 is not acceptable. Therefore, you may need to redo your experimentation or data gathering. Now let's check with our data. With our example, for group data, that's S over X bar times 100%. So you will get approximately 27.07. If we will refer our if we will base our analysis with the agricultural research criteria, therefore our data is still acceptable. We don't have to redo our experiment or survey. For raw data or ungroup data, that's much lower, which is 26.76%. Still, it's acceptable. So that's how we solve using different methods of dispersion or variability. Next, we'll proceed with shape. Now we have skewness and cortosis. Now skewness can be solved using this one. The quantity of 3 times the quantity of x bar minus x kernel divided by s. Take note, x bar is your mean, this is your mean, this is your median. So again, this is your mean, and this is the median. So whether you have group or ungrouped data, you just need to use the mean for the group data and the median for the group data, or the mean for the ungrouped data and the median for the ungrouped data to get the skewness of our data. Now, if your data is more clustered on the left side, then that's called positively skewed. If it's an ideal one, meaning symmetric, if you divide this by 2, then almost they have the same shapes. No, they're symmetric. Now then the skewness, that would mean that the skewness is equal to 0. For negatively skewed data, that's where the data are clustered more on the right side of the your curve. So that's when the skewness is less than 0, meaning when skewness contains negative values. Next is cortosis. And we have this. So this is for ungroup data. The cortosis refers to the height, while skewness refers to the shape. No. So if the height of your data or curve is low or short, then that means the skewness is less than 0. When skewness is equal to 0, that's the ideal one. Then greater than 0, meaning the height of your skewness, the height of your curve or data is this. No, this is actually called the normal curve. This is your normal curve. Now if the height is greater than normal curve, so you'll have skewness is greater than 0. So the task for getting the skewness and cortosis will be given to you. You have these values. You have this formula already. So you'll be tasked to solve for the measures of shapes. Next is we will discuss the measures of data locations. We have 3 types: quartiles, deciles, and percentiles. Quartiles, if you're familiar with basketball, you have first, second, third, fourth quarter. However, we will be dealing only with Q1, Q2, and Q3. This value here refers to the Q sub 0. This one refers to Q sub 1. This one refers to Q sub 3. 2 rather. This one refers to Q sub 3. And the last refers to Q sub 4. Why do we need why is it that we don't calculate Q sub 0 and Q sub 4? Of course, Q sub 0 does not exist, no, because our data, we don't have Q sub 0. So probably that's a 0 value. Q sub 4 refers to the largest or the last value. So the only thing that we need to calculate are Q sub 1, Q sub 2, and Q sub 3. So what value contains Q sub 1? What value contains Q sub 2? What value contains Q sub 3? Same with the deciles. You have D sub 1, D sub 2, until D sub 9. So quarters, deciles, this in tens, just like our decimal, not 10 values, 10 numbers. So meaning our data here is divided by 10, it's divided by 4, and for percentiles, our data is divided by 100. So this is P1, P2, P3, P4, P5, which means until P10. Now, as you can see, we can compare these 3. Our P10 is equal to D sub 1 or D1. Our D2 is equivalent to our P sub 20 or our 20th percentile. Then our Q1 is equivalent to the 25th percentile. Then our D3 is equivalent to the 30th percentile. Same with the other. Our Q3 is equivalent to P75. Our D9 is equivalent to P sub 90. But if you were given the data, especially sorted data, how do we get Q sub 1, Q sub 2, Q sub 3, or D sub 1, D sub 2, P sub 30, P sub 90? Now we will be using a general formula, that is dl sub j is equal to L plus nj over m minus f all over f sub x times cw. dl sub j refers to the data location, Now, if you will use quartile, then we will be using Q. If you use percentile, we'll be using D. If you want to find deciles, rather, you will use D. If you want to get percentiles, then you use P. The sub refers to which part are you going to solve. For example, if you want to solve for Q sub 2, then this will be 2. If you want to solve for D sub 8, so this is D sub 8. Now your J is equal to 8. If you'll be calculating P sub 90, so your J is equal to 90. Your L refers to the lower class boundary of the class interval containing Nj over M, M's term. So therefore, this formula here can be used for group data. So Nj over M's term. So that's N, the sample size, times J divided by M. Now M here would depend on what type of data location are you going to get. If you will be solving for quartiles, then you will use an M which is equal to 4. So our M is equal to 4. If you will be using deciles or getting deciles, then you will be using M which is equal to 10. And if we will be calculating for percentiles, we will be using an M which is equal to 100. Now what's the uppercase F? The uppercase F refers to all the frequencies immediately before the DL sub j is contained, meaning this refers to the frequency before the Nj over M's term. Then F sub x is the frequency of the class interval where Nj over M is located. By the way, it was not presented. For ungrouped data, we can use this equation or formula. You have J times N plus 1 over M. So that will then be the nth data or observation. So this is the calculation. Now recall the table or the group data and the ungrouped data. So based on our, if we will solve first for the group data, now to get our DL sub j, so since we are looking for Q sub 1, so our DL sub j is Q sub 1, which means our j is equal to 1. Then since we are calculating for the quartiles, then we will use an M which is equal to 4. And then our Nj over M is 40 times 1 divided by 4, and that's 10, which means our Q sub 1 is at the 10th value, So recall the table. Now, where is the 10th value located? And that's then after that we can get the class interval. No, the class interval where the 10th data is located. Get the lower class boundary. Now get the lower class boundary, and that's 25.5. Get the frequency of that lower class boundary of that class interval rather. Then get the frequency before the lower class before the get the frequency, the less than cumulative frequency of the interval before your before the 10th, no, where the 10th, before the interval where the 10th data is located. So based on please go back to the table. No, so I have not presented here the table, so you go back to our table. You will see there that L is 25.5, F is 8, F sub x is 9. Then substitute all of these values to our equation. That's Q sub 1 is equal to L, that's 25.5 plus Nj over M is 10 minus F, which is 8, divided by F sub x, which is 9, multiplied by the class weight, which is 5, and that's 26.61, or if we will round it off, that's 27. Therefore, our quartile 1 is 27. For unsorted data or ungroup rather data, so we will use this equation. dl sub j is the j times the quantity of n plus 1 quantity divided by m's data. So we need to get only j, n, and m. So since we are looking for q1, our j is 1, n is 40, m is 40. So that's 1 times 40 plus 1 divided by 4, which means our q sub 1 is the 10.25th data. Take note of the decimal. If you will get a decimal here, then therefore we will separate that one. That's the 10th data and the 0.20th data. No, that's 0.25 times the 11. No, since ang pasabot ani is naibungkig. So we will get the next data to the 10th. So that's the 11th data. So that's 0.25 times the 11th data minus the 10th data. If you would recall our sorted values, no, in our ungroup data, sorted ungroup data, the 11th and the 10th are both 27. So this will just lead to 0, which means our first quartile is 27. So they have the same answers. Next is for the group data. Now what if we will be calculating for d sub 9? So that's dl sub j is d sub 9. L is where n j over m's data is located. So our j is 9 multiplied by n divided by m. That would result to 36 data. Therefore, we will be using the lower class boundary where the 36 data is located. So that's it. Then get the frequencies. Now you have 34 and 4. So check, you can check based on the table. Now recall what's f, recall what's f sub x. So f here, a correction, f refers to the frequency of the previous class intervals before where the lower class boundary is located. So you can also check the less than cumulative frequency before this class interval here. So that's 34, and f sub x is the class interval where this class boundary is located. Sum all of the values, you will get a d sub 9 or 9th decile, which is equal to 48. For raw data or ungroup data, so same, j, you only need to get j, n, and m. So 9 plus the quantity 40 plus 1 divided by 10 is 36.9. Then again, separate these two, 36 and the 0.9. So you have the 36 data plus 0.9 times 37 minus 36 data. Remember that if na decimal, you will get the next, no, if this is 36, so apil na to si 37. So our 37 data is 48, our 36 data is 48. Since 0 man, so 0.9 multiplied by 0 is 0, so our d sub 9 is 48. So they have the same values. Then next, we have what if we will be looking for p sub 85, so the 85th percentile. So same, nj over m is 34. So locate where the 34th data is. Then get the lower class boundary. Get the frequencies before that class interval where the lower class boundary is located. Get the frequency of that class interval. Substitute all the values. Then you will get 46 approximately. Same with ungroup or raw data. Then you will get 46 when rounded. So this is how we calculate measures of data locations. Next is creating a box plot. That's what I've told you in the previous modules. We will create the box plot once we have discussed measures of data location. Now in creating a box plot, we need the following: the smallest observation, so that's our x, uppercase x mean. Then the lower quartile, that is our q sub 1. Our median, which is x curl our upper quartile, which is q sub 3, and our largest value, which is this that's x max. Okay, I'll just erase it. Okay, that's x max, no, uppercase x max. Then we can also use the mean, the mode, and the outliers. There would be times wherein outliers occurs. No, later on we will define what is outlier. Now, the mean will be an x mark in our box plot. You can use a dot for the mode later. This is how we create a box plot. There are two ways. You can use a horizontal box plot or vertical box plot. Others would call it box and whiskers. So this is the instruction. If you would draw a horizontal box plot, this is the instruction. Now, construct a rectangular with the left. So if you will be drawing a vertical box plot, use these terms in the parentheses. Now, an outlier is an observation that is more than 1.5 the IQR. The IQR is the difference of q sub 3 and q sub 1. It's more than 1.5 the distance of the IQR, then we call it outlier. There are two types, mild and extreme outliers. So when you say mild, extreme when observation is more than 3 IQR. Otherwise, if it's only within 1.5 to below to 3, we call it mild outlier. So this is how we create a box plot. If you again, we need the following: x min, q1, x curl, q3, x bar, and x max. So for horizontal measurement, now if you would check the steps, draw a horizontal line. Okay, then these are your whiskers, the smallest and the largest value. So check sa din ha. Do not put yet these whiskers, no, because we will determine first if ulapas ba na sila sa tuang q sub 1 and q sub 3. Therefore, you have to calculate q sub 1 and q sub 3. Now, the difference is get the difference of 42 minus 27. Multiply then by 1.5. Okay, so if you get the product, no, subtract 27 by 1 point so you have 42 minus 27, then multiply them by 1.5. So in your button, you will subtract it by the answer, add it by the answer. So if ang data, so let's calculate na lang. Okay, wait. Let's calculate if naabot tayo outlier or wala. No, though in the figure we don't have outlier, but we have to prove that there are no outliers in our data. So that's 42 minus 27 multiplied by 1.5. So that's 22.5. Okay, 22.5. Okay, so subtract 27 by 22.5. So, sorry for that. Minus 27, and we'll have 4.5. So, beyond 4.5 are outliers. We add this by 22.5. So beyond, no, sorry, 42. Beyond 22.5 is another outlier. So that's 64.5. So again, you have to take note. Below 4.5 is an outlier. Below 64.5 is an outlier. If you would check, our smallest data is 21, or largest data is 55. So this is within the or IQRs, which means we don't have an outlier. So it's okay now to put the whiskers. Then Q1 is here, Q3 is here. So this will be our box. The height of the box would depend on you and how you draw it. Then draw a vertical line. This is for your X curl. This X here refers to the mean or X hat. You can put a dot here if you want to include your X hat or the mode. So same way, if you draw a vertical line, the measurements are here, in the vertical axis. Then you have the minimum and the maximum values, the Q1 and Q3. Then this is your mean, this is your median. If you want to include the mode, so just put a dot for the mode. So that's how we draw we create a box plot. Okay, for your engage, so this will be for your engage. Answer this in your module. So determine, based on this data here, count the number of data. I think it's still 40. Based on the data here, you determine the following. The mean, median, mode. Create a box plot. Check if data are clustered or not, and calculate the 70th and 60th percentile. By the way, these are the answers. Now, before I forgot, this is the equivalent graph or box plot of our engage activity. Now, take note, we have outliers. Okay, so we have 2 outliers, and these are the mean, median, and mode. Now, I used Excel to calculate this, so but again, you have to show your solution. No, manually show your solution. Get the mean, median, mode, standard deviation, so that you can determine if data are clustered or not, together with the C sub V or the coefficient of variation. These are the quartiles, Q sub 1, Q sub 2, and Q sub 3. Now we'll only be needing Q sub 1 and Q sub 3. So again, this would be all. See you on our next discussion.